Okay, this is the end of topic test, the static electricity paper that you did at the end of the first half term. What I'm going to do is I'll spend a couple of minutes on each question going through the physics behind each of the answers, and the idea is you can stop this, go back, watch it as many times as you want until you understand. So, question 1. Right, we've got an atom, and obviously it tells us there that the atom is neutral. Now what it's asking us to do is pair up one of these letters with one of the answers, and this question wasn't answered very well, to be fair, in the test. So what we've got to do is, because the atom is neutral, then you should remember in class we said that there are 3 basic particles that all atoms are made up of. That's protons, neutrons and electrons. Okay, and the protons and neutrons, they live in the nucleus, like this for example, and the electrons, well, they orbit the nucleus around the outside. Okay, and if I wanted to know the charge on each of these, we say that the proton is positive, the neutron has no charge, and the electron is negative. Now this particular atom has 2 protons, 2 neutrons and 2 electrons. This is a helium atom. So helium looks like this on the periodic table. That's the atomic number, 2 protons. That's the mass number, which is the protons and the neutrons. So therefore we must have 2 protons, and we've got to have 2 neutrons to make this number up to 4. Okay, and because it's an atom, it has 2 numbers of 2 protons and also 2 electrons. So if you look at this in terms of charge, we've got the protons is giving us 2 positive charges, the electrons, that's 2 negative charges. So overall 2 positives, 2 negatives gives us no charge. Right, so let's go back to this. Obviously that's just told us that R must be the electron. Okay, so that's your first line across there. R is the electron. The next problem is, well, which one of these 2, the grey or the black, is the protons? So we've got 1, 2, 3, 4, 5, 6 electrons, and I've just told you that the number of protons and electrons has to be the same in each atom, so therefore it must be the greys, that's the protons. 1, 2, 3, 4, 5, 6. 6 electrons, 6 protons, so S must be protons, so that's your next line there. Okay, and by process of elimination, T must be the neutrons. Right, next part. A boy combs his hair using a plastic comb. His hair becomes positively charged. Right, so explain what happens to the boy's hair when it becomes positively charged. Now, if I was just to draw any atom, so let's go 1, 2, 3, 1, 2, 3, 4. Okay, that, as it happens, is lithium, the lithium nucleus. 3 protons, 4 neutrons. Now that nucleus would have 3 electrons because it would have to, because it's got 3 protons. So there's 2 of them, there's the third one. Okay, so there's our lithium atom. Now we're talking about how things become positively charged. Now when you have static electricity, when 2 surfaces rub together, it's always the electrons that are lost. So if I just go back to what I was saying before, we've got 3 positive charges here. I'll just put a little 1, 2, 3. 3 positives and 3 negatives. If I take a negative away, if I was able to sort of scratch that electron off the atom, I'm left with 3 positive charges and only 2 negatives. So 3 pluses and 2 minuses leaves me with an overall positive charge. Okay, so on the question it says, explain what happens to the boy's hair when it becomes positively charged. The answer is, it's lost electrons. So electrons have been transferred from the boy's hair to the comb. Okay, right, the next one. Complete the sentence by putting a cross in the box next to your answer. His plastic comb also becomes charged. If a copper comb was used, it wouldn't become charged. This is because copper is a conductor, and you can't charge conductors in this way. The boy puts his charged comb near some small pieces of paper. Explain what happens. Now the thing here is, it's asking you to explain it, not describe it. So a lot of people on this answer were saying, well, the small pieces of paper will be lifted up to the comb because there's an attraction between the two, which is correct, but it asks you to explain it, so obviously it's a bit more difficult than that. So if we just imagine a small piece of paper, so like the type of stuff you get out of a hole punch, if we imagine that's got a little bit of bad drawing. Like if we imagine that little bit of paper's got a little bit of depth, if I was to zoom in on that piece of paper, so it looked like this, then if I was to bring a negatively charged comb, so imagine that's the teeth on the comb. If this is negatively charged, then it's got electrons, excess electrons on it, which is what all these little dashes are. Then obviously this piece of paper is made up of atoms, so it's got protons and electrons in it. Now electrons, they orbit the protons, so the electrons of the atoms inside the paper will be pushed away by this negatively charged comb. So all your electrons, imagine, would be pushed away down to the bottom of the piece of paper. Okay? And the positive charges, which are the protons or the nucleuses or nuclei, they live there like this in the paper, and all the electrons have now been pushed away and they've sunk down to the bottom. Well, obviously negative and negative will repel, and negative and positive will attract, but because the negative charges are further away than the positive charges, attraction wins. So there's a shorter distance between the negative and the positive than there is between the negative and the negative. So the attractive force is bigger than the repulsive force. Okay? And that's the explanation as to why the small pieces of paper will be attracted to the comb. Okay, question 2. Vicky combs her hair with a plastic hair comb. The comb now has a negative charge. The comb has a negative charge because it has gained electrons. It's always electrons which are transferred in static electricity, never protons. So if it's become negatively charged, it's because it's picked up electrons which are negatively charged. Okay, Vicky's hair has also become charged. Explain how it's become charged. Well, those electrons that have now gone onto the comb, they've come from atoms of Vicky's hair. So Vicky's hair has lost electrons. So the answer is her hair has become charged because it's lost electrons to the comb, or there's been a transfer of electrons from her hair to the comb. So her hair is positively charged, is left positively charged. Right, Vicky holds the comb over a small piece of metal foil. The foil jumps up and sticks to the comb. Show on the diagram where the foil is negatively charged. So if this comb, which it said in the question, was negatively charged, then if this has got, you have to imagine loads of negative charges all over it, loads of electrons, then the electrons that are in the foil will be repelled and pushed down the foil, okay, because those electrons won't want to be anywhere near that charged, that negatively charged comb. So the electrons will be pushed down. So all you've had to do for this one was put a little circle around the bottom of the foil. Okay, next part. Vicky combs her hair with a metal comb. Explain why the metal foil is not picked up by the comb. And the answer to this one is because you cannot charge a conductor with static electricity. Because if you think about it, if it's a conductor, if you're holding it and you're trying to charge that conductor, any excess electrons that you might be able to put onto the conductor, they'd instantly be discharged because you are earthing that conductor. So you can't charge a conductor. So that's your answer. Okay, let me just show you. There's the answer to question. The answers to question 2 if you want to pause it. Okay, right, the next part. The picture shows an electrostatic paint sprayer about to be used to paint a metal object. When the paint particles leave the sprayer, they are negatively charged. Explain the benefits of using this sprayer compared with one that does not charge the paint. Now, the thing with this is, it's a 6-mark question. What you need to know is that you don't need to have 6 correct scientific statements or facts. What you need to do is have maybe 3 or 4 good correct points, but then you need to have them sort of logically explained and written down, and you need to have compared. So explain the benefits of using this sprayer compared with one that does not charge the paint. So all I'm going to do for this one is, if I put the mark scheme up, the point is that if the paint particles have got the same charge, then they'll all spread out from each other. So if they've got the same charge, they'll repel. So they'll be more spread out and form a fine mist. To create even layers of paint, you get a better finish. The opposite charge is induced on the object. So you notice that the object was earthed. Okay, so all it's saying is, if you bring the negatively charged particles to this, they'll be attracted to the earth. Okay, so paint particles are attracted to the metal object. Takes less time, uses less paint is wasted. Okay, allow reverse arguments for uncharged paint. So 6 marks. You needed to have these sort of statements written down logically to get the 6 marks, and you wouldn't have needed all of them, obviously, just a selection of these statements. Okay, because this is the marking criteria. It tells you you either get put instantly in a level 1 answer, a level 2 answer, or a level 3 answer. And if you want to pause it and have a little read through what gets you to level 1, which is only 1 or 2 marks, or what gets you to level 2 answer, which is 3 or 4 marks, or level 3 answer, which is 5 or 6 marks, then you can have a little read of those statements. I'll leave that to you.